Today, we're going to add edge outlines to our custom lighting models. Let's go. All right, so we're in the middle of a series of videos on creating custom lighting models. Last week, I showed you how to create the URP custom lighting model, and the week before that, I showed you how to create the specular highlights from the URP lighting model. What we're looking at here is a lighting model we created imitating the appearance as if the scene were rendered with colored pencils. So far we've created a whole set of different lighting models. And if we switch over to our shader, here you can see all of our lighting models represented by subgraphs. Here's the one we created last week. Here's the colored pencil lighting model that we're currently looking at. We've got colorized lighting, lighting from film noir, some basic lighting that renders really quickly. We've got tune lighting. Let's take a look at that one. We'll just wire this up and save it and switch back to our scene. Now we've got a scene that's rendered with tune rendering. And we've got a whole list of other lighting models here that we've created throughout this series. If you'd like to see any of the previous videos in the series, I'll link the playlist to the whole series down below so that you can go back and watch these videos and see how to make these lighting models. In today's video, we're not going to make a new lighting model, but I'm going to show you how to add edge outlines. And the reason that I'm doing this is because some of these stylized lighting models, especially like these tune rendering ones and the colored pencil rendering outlines, the colored pencil rendering really could use or could benefit from having the edges outlined. And so that's what we're going to look at today, just to complete the look of these stylized rendering models. Now, I can hear some of you saying, but you already made a video on this topic 2 years ago. Okay, well, that's true. And what that means is I'm going to link that previous video that I already created showing how to make cartoon outlines down in the description. In that video, I go into minute detail and we build the cartoon outline shader step by step. And so if you want to see exactly how every step of this process is done, check the link in the description, go back and take a look at that video, and I'll show you exactly how to do it. In today's video, we're going to cover the outline shader at a little bit higher level. I'll show high-level concepts, and then I'll show you a few tips for improving it. All right, so let's go ahead and get started. The first thing that we're going to do is we need to select this is in the settings PC folder, and I'm going to select PC high renderer. And in your project, assuming you're using URP, you can select your universal render data asset. And down here at the bottom, there's this section called renderer features. By the way, I'm covering all of this in Unity right now, but in a minute, I'm also going to switch over to Unreal, and I'll show you how to add these edge outlines with a post-process shader in that game engine as well. All right, and that's what this is. It's going to be applied as a post-process. So I'm going to click this Add Renderer Feature button, and we're going to add a full screen pass renderer feature. Now, by default, it's adding this full screen invert colors render pass, and that's going to make everything look like it's rendered negative, which is really not the effect that we're going for. So what we're going to do instead is I'm going to come in here and I'll type post-process, and we're going to pick our post-process tune outlines material there. Okay, so this is a material that I've already created, and you're going to be saying, but I don't have that one. Where do I get it? Well, I'm going to show you how to make it. So we'll select this material. I'll come over here and hit edit, and we'll open up our post-process Toon Outlines shader. Okay, the first thing to know about this shader when you're making a post-process shader is that you need to set the material type to full screen. You know, here we have lit and unlit and decal, so be sure you set the material type to full screen, and that way you are creating a shader that can be applied as a post-process. So just to give you a really broad overview of what this shader is doing, we're basically finding the edges in our scene. And there are two ways to find edges. You can find edges based on depth, and you can find edges based on changes in normal. And let me show you what I mean. We're going to switch back to our scene here. So if I take a look at this tree here, there's an edge that's based on depth right here because there's a change. I'm looking for changes in the distance. So if I look at the edge of this tree, you can see that the sky behind the tree is really far away, and then this tree branch here is relatively close to the camera. And so we need to put an edge right there where there's a change in depth. And then the other way that we measure where edges need to go is with changes in normals. And this edge right here, where the branch connects to the trunk, is a good example of that. This branch has normals that are pointing kind of to the left of the scene, and the tree has normals that are pointing kind of to the right. And so where there's that seam between this branch and the trunk of the tree, there's a kind of a 90-degree change in the normals facing one way and then the normals facing the other way. So we need outlines around changes in normal, and we need outlines in changes in depth. And we've got both of those happening in this particular shader. And the way that we detect those edges is we take the pixel that we're currently rendering and we look at 4 pixels that are around it, and we take a look at the normals and the depth of those 4 pixels, and then we compare them with each other to see if there's a change. So let's go through the process and I'll show you how we're doing all of this. The first thing that we need to do is identify those 4 pixels that we're setting up. And the way that we do that is by offsetting from the current pixel that we're rendering. And so these vector 2 nodes here are giving us offsets from the pixel that we're currently rendering. So we go offsetting -1 and 1, 1 and -1, 1 and 1, and -1 and 1. So we're basically taking 4 pixels kind of diagonally around the pixel that we're currently rendering. We multiply those offset values by an edge thickness. And if we take a look here in our blackboard, we have our edge thickness parameter that's exposed, and we're defaulting that to a value of 1.5. If we switch back to our scene here, you can see that with this material selected, I have this edge thickness value, and I can set this to be like 4 to get really thick edges, or I can set it to 1 or something like 0.5 to get really thin and subtle edges. So I'm able to customize the way that my material is working. So we're multiplying these offset values by this edge thickness, and what that does is it moves those pixels that we've selected to sample around the pixel that we're currently rendering. It moves them further away from our center pixel. And then, in order to get the aspect ratio correct for those offset pixels, we're dividing the offset by the width and height of the screen. And that allows us to convert these values of -1 and 1 away from the center pixel into values that correspond with how many pixels across and down we have in our screen. So we divide each of our samples by the width and height of our screen to convert into that value range. And then we add those offsets to our screen position. And this is where we create our coordinates. So this is the screen position where we're currently rendering. And we add that position to the offset that we've calculated for each of those pixels. And so these 4 add nodes are going to give us the final coordinates that we need to sample either our normal or our depth. All right, so there we are sampling our coordinates. And like I said, if you need more detail or you need to go step by step through this, I've linked the previous video that I made 2 years ago down in the description. So take a look at that to go through this step by step. Okay, so the next thing that we're going to do is use these coordinates to sample our normals from the screen. So I'm using this node called URP sample buffer. And in the video that I made last time, I was actually making it for HDRP, and so I didn't do a URP version. And so it's important to note now I'm using the URP sample buffer, and I've set the source buffer to normal in world space. So this is going to sample all of the normals on the screen, but in the specific location of the pixel offsets that I've done. So you can see here, I'm offsetting by these values here, and then I'm sampling the normal vector or the normal buffer on the screen right around the pixel that I'm currently rendering. Okay, the next thing that I need to do is adjust the range of those normals, because these normals are in a range of -1 to 1, but in order to compare them properly, I need them to be in a range of 0 to 1. And so in order to adjust that range, I'm multiplying by 0.5 and then adding 0.5. And that's going to shift their range from the -1 to 1 to 0 to 1. And that's what I've done to each of my normal samples with these nodes here. All right, and then the next thing that I need to do is compare those normals. So I have a normal at one corner and another corner, and I'm subtracting one from the other to see what the difference is. And then whether the difference is positive or negative, I take the absolute value so that I can find the same difference whether it happens to be negative or positive. And so I do that with these 2 corners, and then I also do that with these 2 corners. I subtract one from the other and then get the absolute value. And then I take the results of that and I add those results together. And that's going to give me all of the differences in the normals kind of accumulated. And then the normals have an X, a Y, and a Z component, and I'm performing these operations on all 3 of them at once. But here what I do is I find whichever of those differences that I calculated is the greatest between the X, the Y, and the Z. And I'm doing that by taking the maximum of the first 2 channels, and then the maximum of that, and the 3rd channel. And so that's going to give me the greatest amount of difference between all of those normals. And then here at the end, I use an inverse lerp node to readjust the results of all of those normal differences that I calculated. And I'm taking a value of 0.2 and a value of 0.5, adding those together. And so basically there's a space of from 0.2 to 0.7 for the A and the B of the inverse lerp. And the last time I did this, I used a smooth step node instead of inverse lerp. But I found that you can get slightly better performance, improved performance, by using inverse lerp instead of smooth step. All right, so that is going to give me an outline based on the difference between the normals of the normals that are around the pixel that I'm currently rendering. And so here I'm going to combine that outline with the difference in depth that I've found. So we should go over that. So let's come down here, and you can see that just like I sampled the normals all around the pixel that I'm currently rendering, now I'm sampling the scene depth just the same. So I have my scene depth node, and it's set to linear. And I have 4 of those scene depth nodes, all set to linear. And then I'm comparing the depth of this one with the depth of this one by using a subtract. So I'm finding the difference between those. And then again, just like I did with the normals, whether that difference is positive or negative, I use the absolute value because I want the difference, and it doesn't matter whether it's positive or negative. So I compare these two diagonal depth values, and I compare these two diagonal depth values, and then I add the result together so that I'm accumulating all of those differences. And then I divide those differences by whichever depth is the greatest. So here I'm taking this depth, this depth, this depth, and this depth, and I'm kind of stacking these maximum nodes to find whichever of those is the furthest away. And I divide my accumulated depth differences by the greatest depth, and then I saturate that. And then again, just like I did with the normals, I'm using the inverse lerp node to adjust it's kind of like a contrast adjustment, right? So I'm making a 0.1 as the A value, and then 0.1 plus 0.1 as the B value. And so this is going to be a value of 0.1, and this is going to be a value of 0.2. So that's basically the range where I'm expanding that range to 0 to 1 with my inverse lerp. And by the way, you can adjust these values yourself. If you don't like the way the outlines are coming out, you can tweak this value for the depth comparison, and you can also tweak these values for the normal comparison to adjust the way the outlines are working for the normals and for the depth. So here I've got outlines based on normals, and here I've got outlines based on depth. And I'm going to find whichever of those is greater and then saturate the result. And then that is going to become my mask for the outlines in my scene. And now what I do with this mask, and by the way, it's going to be white wherever there's an edge, and it's going to be black wherever there's not an edge. So at this point, I have a choice of what I want to do. And I'm going to show you something that I chose to do in this particular case that's different from the video that I made 2 years ago. 2 years ago, I said, well, I'm going to take my screen buffer. This is just the rendering of the screen as it is. And I'm going to blend between that, and I'm just going to disconnect this here. I'm going to blend between the screen buffer and a color value. In fact, I'll just go ahead and add a color node in here. I'm going to blend between the screen buffer and black, and that is going to be my outline. So let's just take a look and see what we get in this case. Okay, so now you can see that I've got these black outlines around everything. But what I decided is that for these stylized rendering lighting models that I've created, it would be a lot more interesting if my outlines are actually colorized. Right now, they're kind of like the maximum amount of contrast. They're either black or they're not. But what if we could make outlines that were the color of the scene behind the outline, but just adjusted a little bit? And so here's where I'm going to differ from what I did 2 years ago. What I've done here is I've taken my scene rendering and I've added this saturation node, and I've given it a value of 2 for saturation. And then I've multiplied it by 0.2. So let's just wire this directly into our output result and see what we get, just so you can get an idea of what I'm doing here. All right, so what you can see here is that I'm increasing the saturation of my scene and I'm darkening it. So I'm giving it a saturation of 2, and then I'm multiplying it by 0.2. And these are the color values that I'm going to be using for my edges. And so if I take my scene, I saturate it, I darken it, and then I blend between the original scene color and my darkened, more saturated version. I blend between the original and the darkened, more saturated based on the outline color. Now the outlines in my scene are going to be the same color as the scene behind them, but they're darker and more saturated. I hope that makes sense. I hope you're able to follow along. So Now, instead of just being flat black, the outlines that I'm rendering are actually adapting to the scene. So the outlines that are around this roof area over here are going to be like a darker blue. And the outlines that are around my tree are going to be kind of a darker brown. And the outlines that are around the flowers are going to be like purple and pink, but a darker version of that. And so I'm able to get these outlines that feel like they fit into the scene much more closely than I did if they were just a flat color. And I really like the idea of being able to control the outlines this way. So this is what it looks like using my toon rendering lighting model. Let's go ahead and switch over really quickly to the colored pencil lighting model and see what the outlines look like there. So I'm just going to grab my pencil lighting here and connect it up and save it. Then we'll switch to our scene. And you can see that these outlines are going to blend in really nicely and support the stylized rendering. So I've got the stylized rendering, which is kind of like a crosshatch pattern, and it's providing the lighting. But then I've got these nice edge outlines, which are defining the shapes and outlining all of the objects based on their depth and their normal. And it just really serves to improve this stylized rendering that we're creating and just really give that last little bit of support that the stylized rendering needs in order to kind of push it over the top and make it feel finished. So that's it for today's video. I hope you enjoyed this and that you learned how to create these post-process effects. It's pretty simple. And by the way, once you get to this point where you've combined the normals and the depth outlines, you can use this mask to do all kinds of different things. I'd be interested to see what kinds of solutions you come up with for this portion of the post-process shader where you are using that mask to generate your final lines. Do you have a different solution than I came up with here? I'd love to hear it. All right, that's it for the Unity version of our cartoon outlines. Let's go ahead and switch over to Unreal, and I'll show you how to do the same thing there. All right, here we are in Unreal, and just like we just did in Unity, we're going to add our edge outlines to our scene. So here's the object that I've been using. Just have a sphere here, and we've applied that same kind of colored pencil drawing style to this object as we did in our Unity scene. So in order to create a post-process shader in Unreal, what I need to do is select my global post-process volume for my scene here. And then for the settings of that, I need to come down here to the rendering features and open that up. And then under here, there's this entry called post-process materials. And I'm going to open that. And there's an array here, which is a list. And I can add multiple post-process materials. But in my case, I just want to add one. So I'm going to hit the plus here to add an element to this array. And now it's going to allow me to choose a material. So I'm going to pick add reference. And then I'm going to pick use selected asset from the content browser. So if I open my content browser here, you can see that I've got this test post-process detect edges selected. So when I hit this arrow here, it plugs that right into my slot. And now I've got these nice edges assigned, or the post-process shader is working, and it's going to create these edges around everything in my scene. So that's great. That's exactly what I was looking for. Now, if I wanted to add more post-process effects, I could just keep hitting this plus and add more and more of them. But in my case, what I want to do is show you this shader and how it works. So let's switch over to our test post-process detect edges shader. And I'm going to walk you through this and show you what it's doing. The first thing that's important to do when you make this kind of material is to make sure that you set the material domain to post-process. And when you do that, it's going to take your root node and gray out everything except for emissive color. This is a shader that runs on the scene, so it takes the scene and runs some kind of an effect on the scene and then gives you the result. And really the scene, all it is color. It doesn't have normal or roughness or specular or any of that stuff. So it's just working on the color of the scene. All right, so let's take a really broad overview of this shader, and then we'll kind of zoom in and I'll show you some more specifics. So what we want to do when we're creating a toon outline like this is find out where the edges are and put an outline in those locations. And the way that we find edges is by comparing normals and by comparing depth. These are two different methods, and in this shader we're actually using both of them to do something to use the strengths of both to combine to find edges in a better way. And so what we need to do is sample the pixels around the pixel that we're currently rendering and compare the depth and the edges in those surrounding pixels. And if there's a big difference between them, then we're going to mark that as an edge. And so we need to find 4 pixels that are in close proximity to the pixel we're rendering. Then we need to get the normals and the depth in those 4 adjacent pixels. And then we need to compare them to see how similar or different they are. So that's what we're going to do. Here we're creating coordinates for those 4 pixels. Here we're comparing the normals. And then down here, we're comparing the depth. And then once we get the depth or the difference between the normals and the depth, we combine those together here. And then the result coming out of here becomes a mask that we can use to create our final result. And I'll get to the final result in a minute, but let's kind of start over here and I'll show you how we set up these coordinates for our neighboring pixels. So we want a pixel that is in the upper left, in the upper right, in the lower left, and the lower right of the pixel that we're currently rendering. And so I'm just going to create these vector 2 nodes, -1, 1, 1, -1, 1, 1, and -1, 1. So these are in each diagonal corner away from the pixel that we're currently rendering. And in order to have some control to be able to scale the width of our outlines, I'm going to multiply these offset values by a constant value here, this value of 1. And I can use this value to control the thickness of my outline. So if we look at our sphere over here in our preview, if I set this to 3, it's going to compile, and now we have a much thicker outline. So this offset, or this value here, times 3, is going to push these offset values away from the center and the result is that our outline is going to be a lot thicker. All right, then I need to divide these values by the size of the screen. So this view size node that I'm bringing in is the width of the screen, the width and the height in pixels. And I'm dividing my offset values by that to put these offset values in screen space. And then I'm adding my offset values to the screen position. So this screen position node that I have here is just kind of like the coordinates on the screen. And it's going to default to the pixel that I'm currently rendering, but I'm adding offsets for -1, 1, 1, -1, 1, 1, and -1, -1. And so now the result of these add nodes here is that I have 4 values that are on the upper left, upper right, lower left, and lower right corners away from or adjacent to the pixel that I'm currently rendering. So I can use these offset values to now sample the normals and sample the depth. All right, so let's talk about the normals first. In order to sample the normals, I'm passing those 4 UV offset values into my scene texture node. You can see that I'm doing this 4 times. So I've got the scene texture node set to world normal. There's a bunch of different options here of things that you can sample, but I'm sampling the world normal at each of those 4 corners around the pixel that I'm currently rendering. And the world normal comes in with a value range between -1 and 1. And in order to compare things correctly, I actually need them to be in the range of 0 to 1. And so I'll take this sample and I'll multiply it by 5 and multiply by 0.5 and add 0.5. And that adjusts the range from -1 to 1 to just 0 to 1. So that's what these nodes are doing here. I'm adjusting the range of my normal coming in. And then once I've got those ranges adjusted, I can compare these 2 normals that I've just sampled. One is on one corner and then the other is on the corner, kitty corner to it. And I'll subtract one from the other to see what the differences are between them. And then I'm using the absolute node to, if the differences are negative or positive, it doesn't matter to me. I just need all the differences. So I'm using absolute to make the differences that used to be negative positive again. So I found the difference between these 2 kitty corner normals. And then I do the same thing for these 2 normals. And then I find the absolute value, and then I add all of those differences together. So I'm accumulating them. And now the last thing that I need to do is my normals are actually, they have an X, a Y, and a Z component. And I've found the difference between all 3 of those, but I need to find whichever of those is the biggest, whichever difference is the most. And I do that by finding the maximum value between X and Y, or R and G, and then the maximum value between that and the Z component. So I've found the one that's the greatest. And then the last thing that I do is this results in kind of an interesting looking gradient. And I need to adjust the contrast and kind of fine tune it a little bit. And so I'm using this inverse lerp node to narrow down the gradient and just take a small band of that gradient to kind of refine that edge. And that gives me my final result. So I think in the video that I did 2 years ago, I used a smooth step node here, but I found that if you use an inverse lerp, you can get the same or very similar results for a bit cheaper, a little bit less math to do an inverse lerp than a smooth step. Now these values here, this 0.2 and the 0.5, these are tunable. So if you find that you're getting an outline that's a little bit too feathered, or maybe the gradient's a little bit too soft, you can adjust these values, make them closer together or farther apart from each other to adjust the results that you're getting from the normals. All right, so the result of my inverse lerp node here is going to be the edges that I've found from the normals. And then if we come down here, you can see that I'm doing something very similar. I'm taking the 4 coordinates for sampling pixels, and instead of sampling normals like I'm doing here, down here at the bottom, I'm sampling depth. So you can see that I'm passing those UV coordinates into my scene depth node, and I'm doing that once for each of those 4 corner pixels around the center. And then again, I'm subtracting them to find the difference between those 2 depth values, and using an absolute node to make negative values positive, so all differences are the same. And then I'm adding these differences that I've found together with these differences to kind of accumulate all of the differences. And then I'm going to find whichever of these depth values is the greatest. And I'm doing that using this maximum node here. So I find whichever of these 2 is the greatest, and then the result of that and this one, and the result of that and this one. So now I've found, using these 3 max nodes here, I've found the depth node with the highest value, and I divide my differences by that highest value. And this is kind of normalizing the result. so that I can bring that into a usable range. Then I saturate the value, and again, I'm using an inverse lerp node to kind of fine-tune the gradient that I've created. I'm using a value of 0.1, and then this 0.1 plus 0.1 here, I'm adding those two values together, so I'm doing an inverse lerp between 0.1 and 0.2 using this gradient that I'm passing in as the value input. So this is just to kind of fine-tune and adjust the contrast and range of that gradient that I'm passing in. So I've accumulated the depth differences and the normal differences, and then I'm using this max here to find whichever of those is greater. So the normal is going to create some outlines, and the depth is going to create some outlines, and then whichever is greater, I'm combining those together. Now this multiply here is not strictly required, but you could use it to make your outlines like more opaque or more transparent if you wanted to. So this is going to give you your final mask, and the mask is going to be white where the edges are, and it's going to be black where the edges are not. So then you can use that to get whatever kind of results you're looking for. And so in my case, I'm going to use it to lerp between a couple of things. I want the rest of the scene to be there. And so wherever the edges are not, I need to pass in this node, this scene texture post-process input 0. So that's going to give me the whole scene just the way it is. And just so I can show you what's going on there, if I pass the result of this post-process input 0, I'm going to get the scene with no changes applied to it. So I'm going to pass that into my into the A input port of my lerp. And then for the B input port, this is whatever I want my edges to be. So if I take a color like this is just a black color, and we save the result here. Now you can see I've just got hard black edges. But whatever I pass into this is going to be the color of my outlines. So what I decided to do is to take the scene color and saturate it, which means make the colors more bright and vibrant. So I've passed my scene color into this desaturation node. I can just delete this 2 here. I don't need that. I've taken my scene color and passed it into this desaturation node. And then I passed in a value of -2, -2, -2. And what this is going to do, instead of desaturating, because I'm passing in my negative values, it's actually going to saturate. So if I take the result of this and pass it in, now you can see the scene that's getting rendered, the colors are much more vibrant. That's what it means to give negative values to the desaturate node. And then I also took those like more color vibrant colors, and I multiplied by 0.2. So if I take the result of this and pass it in, now you can see I've made it darker. Now, of course, it's going to apply the auto exposure here. But let me just set this to a value of -1. So there you go. So if we pass the post-process value in directly there, this is what we get. But if we pass in this one, we've got colors that are more saturated and darker. And that's what we want to use for our outline colors. So I'm going to take this value and pass that in. Instead of just a hard-coded value like we were doing before, I'm going to make our outline colors the same color as the scene, but more saturated and darker. So now when I pass this in, I'm going to get an outline that is, again, it's the same color as the scene, but more saturated and dark. Okay, I just found that I need to add a saturate node here because the results that I was getting were outside the 0 to 1 range. So in order for this lerp to work correctly, I needed to saturate the values coming out of my normal compare and my depth compare. So now that I've done that, I'm able to blend correctly between my base scene color and the version of that color that is darker and more saturated. So now maybe we can switch it back to a value of 0.2. Yeah, so now you can see I'm getting, wherever the scene is showing up here, I'm getting values that are darker and more saturated as my outline colors, which gives a result that feels a little bit more natural. So let's switch back to my scene. And now you can see that that outline is the color of the objects behind it, but a little bit darker and a little bit more saturated. Let's take a look at the size of the outline. I think they're maybe just a little bit too thick here. Yeah, I've still got it set to 3. Let's just set this to 1 and we'll save the result and switch back to our test scene. And now you can see as I fly around that all my objects have these nice outlines around them, and the outlines are similar to the colors that they're outlining instead of just being hard coded values. So around the trees, I'm getting some nice green outlines, and around the bush here, you know, I can see these outlines are green to kind of match the green of the leaves, and the outline around the trunk bark is brown. So yeah, so I get a little bit more natural feeling outlines. And if my scene were rendered completely with this colored pencil custom lighting model, it would match really nicely with these post-process outlines that I just created. All right, so I wanted to do this video today with showing how to do these post-process edge outlines to kind of wrap up the idea of combining post-processing and custom lighting so that we can get a result that's like really nice and cohesive. I hope you enjoyed the video today. And I look forward to sharing future videos with you. So if you like this content, be sure to subscribe and let me know what you think down in the comments. And have a great week, everybody. We'll see you next time.